Hello, welcome back to How to Get an HD in Business Modeling. I'm Reza, and today we're looking at another question from Chapter 8, question 57. It says, a survey from 499 women revealed that 38% wear flats at work, flat shoes basically. Use this sample information to develop a 99% confidence interval for the population proportion of women who wear flats to work. Okay, so it's a confidence interval question. However, it talks about population proportion. Another trick is to pay attention to the 38% of a sample. So it says there is a survey of 499 and 38% of them do particular things. So you're dealing with a proportion here. Okay. So let's write down what the question is telling us. I know that the question is telling us that sample size is 499. It also gives us a proportion. P is 38%. And I'm after 99% confidence interval. Okay. If I write the formula, it would give me some idea. So P plus minus Z times square root of P times 1 minus P over N. That's the formula for a confidence interval of proportion, and I need to draw a graph to have a better idea what is happening. So 99%, so that's 99% in the middle, and that's the middle value, and I'm after these values here. Yeah. Okay, I have N, I have P, which is 38%, so the only thing I need to find is Z. To get Z value, if I go to the Z distribution, normal distribution, you can see I need to find the area from 0 to the value of interest, then I can identify Z. So from 0 to this part, how much is that? It's quite important to figure it out how much this area. If I change the color. So from middle value to the point, how much is that? So it's basically 99% divided by 2, which is 49.5%. Okay, if I go to the table, I need to find 49.5 in the body of the table, then I can read the Z value. 49.5. Okay, look at these two values here. 0.4949, 0.4951. So they're away from 0.495 with the same distance. So the value of interest would be 2.575. So that value would be 2.575. Z from here would be 2.575. Okay, the rest is straightforward. I just need to plug in the values. It would be 0.38 plus minus 2.575 times square root of 0.38 times 1 minus 0.38 would give you 0.62 divided by 499. If you calculate this part, it should be 0.056, and adding 0.056 to 0.38 would give you the upper limit of 0.436, and lower limit of, basically when you deduct 0.056 from 0.38, 0.324. So now we can say that you would be 99% confidence that the true population proportion, look at that, population proportion, true population proportion of women who were flat at work is between 0.324 and 0.436. Okay, that's part A of the question. Part B of the question says, suppose we also wish to estimate the proportion of women who wear athletic shoes to work with a margin of error of 0.01 with 95% confidence. Determine the sample size required. Okay, now I have a different confidence level. I have margin of error here, and I'm looking for sample size. Okay, let's write what we've got. So we have a margin of error as 0.01. We know that confidence level is 95%. And formula for a sample size is n z square times b times 1 minus b over e square. That's the formula you get from the formula sheet. I have e, I don't know z, and I don't know the p. So what about z? From confidence interval I can find what is the value for z. So if I try the distribution again, 0 from here to here is 95%. I'm after these values here, positive z and a negative z. As you know, so I need to go to the table. From the body of the table, read the z value. But what's the area that I'm after? So let's change this. So this area is the area of interest. This area is 95% divided by 2, which would be 47.5%. Okay, so that's 47.5%. If I go to the body of the table, for 47.5, okay, I have exact value for 0.475, which is 1.96. Good. So z value from here, that would give me z value of 1.96. This would be minus 1.96. Okay, remember, I mentioned in the class that you need to memorize a couple of important z values. One of them is for 95%, one of them was for 99%. Quite practical to memorize these values, because every time you need to go back to the table and find these values would be a little bit difficult. So if you memorize them, it would be easier to solve the questions, because 95% is a typical confidence level. Now, okay, I have z value, I have e. What about p? P is not given. What should we do about that? Okay, so remember, when you don't have the value for p, you need to just think, how can I maximize sample size? Because the larger the sample is, the better, the more accurate result you would get from the estimation of your population values. So I want to maximize n, and the value that make n the largest is the value that make the numerator the largest. So if you try different values, remember this value p and 1 minus p move in the opposite direction. So if I put p, for example, 0.2, this would be 0.8. If it's 0.3, this would be 0.7. The largest value I would get is from p 0.5, because basically I would have 0.5 times 0.5, and that would be the maximum value for the numerator. Okay, so that's a trick, remember that. So if p is not given to you, you go for 0.5. Now I have everything to solve this equation. N equal to z is 1.96 squared times 0.5 squared is 0.01 squared, and if you solve this you would get 9,604. 9,604. Remember, if you get any decimal points, you need to round it up to the next value, because always we're looking for a larger sample size. Okay, perfect. So I hope you learned the trick of this question, and see you next time in another video.